So at the end of the last video, I looked one too far ahead. I suggested that the example in 9.3 at the very bottom in program 9-7, I hate all these dashes, was decrementing our way through a pointer, and that's this one. So I did put that note, I hope, at the end of 9.3's video, and if not, you've heard it here, just in case. I forget sometimes. What we're saying here in 9.4 is we can do a little bit of rudimentary math. Please stick to rudimentary math with our pointer values. The way we're going to use it here is plus plus and minus because, again, if you think back to 276 and you think all the way back to, I believe it would be chapter 3 and 4, when we're finally looking at loops, and we look at the for loop and we say, can you do mathematical operations with your increment value? So can you say, for, and then inside of your statement, I equals 0, I less than size, I times equals 2. Yes, but you're a donkey if you do, because that's, number one, complete and total bullshit, because number two, nobody's looking for that. So could you do it? Yes. Should you do it? No. And here is the same. So when we're looking at arithmetic with pointers, please, please, please stick to adding and subtracting, because otherwise you're going to mess somebody up, and then they're going to come look at you, and by look at, I mean come to damage you. So here in 9.4, which is on page 517, we'll walk through the example here, and I will have this again with the code sample stuff. So you'll see another example of this, but I think that this one is actually fairly easy, fairly descriptive, and it does help with 9.4, so 5, 6, and 7 as we continue on here. So what we're doing, because this is the clearest and most concise example that they've built, because it's sitting here by itself in 9.4. So what we're saying is we have a constant int size equals 8. You're on board with that. Here on line number 8, I know you're on board with, I hate this. There we go. I have to go the other way, and it's disturbing my calm. There we go. So here we are using the size of set to declare our array and to initialize it with values. You know exactly what's going on here. Line number 9, this is where we are declaring our pointer. So we are saying it's a pointer to an integer value, and there again is equals null pointer. So that is providing us with a default value for that. It's going to point to a pointer at 0, which is just a holdover value. And then we have count, because we're going to need to know how big our array is so that we can iterate through it. Here, come on line 13, we're going to make our null pointer point to our array. This, I know, is going to bother some of you, and that's why we're spending the extra time here on a page, or on a part of the chapter that's literally like 2 pages. What we're saying here, null pointer equals set. We are not giving to null pointer the values stored in our array, and remember, our array is called set. What we are really doing here is saying that the pointer to the first value in our array called set is we're going to take that value and we're going to put it into it's called num pointer here. So this way we are saying that we are making them equivalent, that the pointer to the first value in set is going to be what we assign to num pointer here, so that after we've declared and initialized and made the space, and C++ has done what it can do to manage all of that stuff that it has to do, now instead of num pointer pointing to null, which ain't nothing. It points to the actual storage location of set instead. So I know that's a lot of words, but it's not an assignment. So this is not getting the values there. This is simply getting the location, the pointer for set assigned to num pointer. So we are using pointer to display the array contents here. We saw this in the previous example from 9.3, but we'll walk through it just really, really briefly again. You'll notice here on line 19, instead of instead of the cout with our array and subscript, instead of that, we are using the counter for num pointer, and we are simply using the address of, and again, it is num pointer, the address of num pointer to point to the next element in our integer array. So it's the other side of that same coin. So instead of using count to point to a subscript, we are using count to increment num pointer, which is, remember, it's not an integer value, it's a pointer. It's a pointer that points to an integer value. So because we know where set begins, because we know that set is an integer array, when we increment through our integer array and we use num pointer as a pointer to a reference there, when we increment num pointer, we're not adding 1 to it. We're going to the next element's storage location in that array. It's just different from how we've been using arrays to date. So here, to display the elements in our array, it's very picky. We're going to display them in reverse order. So we were incrementing num pointer so that it pointed to the last element in our array. And we were doing that from lines 15 through 21. What we're doing here in 23 through 29 is we're starting at the back of the array and we're decrementing num pointer. So remember, we're not decrementing the value stored in num pointer. We're decrementing from one pointer address to another pointer address to the next pointer address, and that's how this works. So this is another one that we're going to come back and we're going to see with different values later in one of our code samples. But you know, I think taking the time to really go over that here helps with the remaining 4 portions of this chapter. We're not doing math on the value stored in the pointer, because remember, the pointer is just an address. We can't do anything with it. We can show you what is there. We can move from one address to another, but we're not actually doing math with it. So the idea here of pointer arithmetic is a little bit of a to you. We're not really doing arithmetic with it. We are simply going from, you know, one pointer inside of an array to wherever the next pointer or whatever the previous pointer was in that array.